So this is the last section we're going to do, Chapter 9, Sequences, and we're looking at Section 9.3, Geometric Sequences. So this is going to sound pretty familiar because the first thing we're going to do is determine if a sequence is geometric. So we're mainly looking at arithmetic and geometric sequences, so those are really the only two that you're going to have to determine. Then we're going to find a formula for a geometric sequence. Find the sum of a geometric sequence. And then the last thing is unique to the geometric sequence of we're going to determine whether a geometric series, so now this is series where we're adding together the terms, converges. So that's going to be a new word we're going to learn, or diverges. Converges is a coming together. Diverges is a going away from. And then we're not going to do the fifth objective in the section. So we're first going to determine if a sequence is geometric. So in a geometric sequence, the ratio of successive terms. So successive means if you have a first term and a second term and a third term, this is the first term, this is the second, this is the third. So each successive term, it means in order, one after the other. So the ratio of successive terms is always the same non-zero number in order for a sequence to be called geometric. So a geometric sequence is defined recursively. So again, that means you look to the previous term to figure out how to make the next term. So some of the really simple ones you already know is, like, if we take a number like 3 and multiply it by 2, 6, and multiply it by 2, 12, and multiply it by 2, 24. That's a geometric sequence. So if you take 6 and divide it by 3, you get 2. If you take 12 and divide it by 6, you get 2. So to get the next term, you multiply the previous term by a number r. So A is the first term again, so that's nice that that's consistent with arithmetic. But the non-zero number r is called the common ratio. Okay, so for arithmetic, we have common difference, d, and for geometric, we have common ratio, we call r. So it's nice we use a letter that makes sense. So the terms of a geometric sequence follow a pattern, and you can see by this example one I gave you that you have a first term like 3, you multiply by r, that's 6. Well, if you multiply by r again, that's what it means to say r squared, right? And then multiply by 2 again, that's what it means to say multiply by r cubed. So let's look at how the pattern works again and say, well, if n equals 1, 2, 3, 4, you see again that the pattern is it's going to be n minus 1 as the exponent on the r because we don't have an r on the first term. So the numbers are 1 off from the counter or index of the sequence number. So let's show that a sequence is geometric by finding the common ratio. So let's write out the first 4 terms. So let's do n equals 1, 2, 3, 4. So when n is 1, 3 to the 1 is 3 over 9. When n is 2, I have 9 over 9. When n is 3, I have 27 over 9. When n is 4, I have 81 over 9. So it looks like I'm multiplying by 3 to get to the next term. So let's reduce these and get 1/3, 1, 3, 9, and so on. So the way you find the common ratio is you say, what's 1 divided by 1/3? How about 3 divided by 1? How about 9 divided by 3? And I keep getting 3. So the common ratio is 3. So that's the find the common ratio part. And we wrote out the first 4 terms. So to show that the sequence is geometric, we did that by showing that the ratio of successive terms keeps being the same number, 3. So we're going to look at number 18 in class together, or you could do it at home in advance and look at how that works. So the second objective is going to be looking at the geometric sequence and seeing if we can find a formula for it. So again, we're still looking at a sequence, and we're trying to find a formula for a geometric sequence. Okay, so we noticed that if you keep multiplying by r and keep multiplying by r, successive multiplication is really what exponents mean, right? They mean multiply again and again and again. So notice that the fifth term has 4 r's multiplying it. So that's r to the 4th. The 4th term gets multiplied by r 3 times. So the nth term gets multiplied by r n minus 1 times. So in our first example, we had the first term, let me back up here, the first term was 3, and the r was 2. And so if I wanted to know what was the 15th term, sorry about the ride there, if I wanted to know what was the 15th term, it would be a1 of 3 times the r, which is 2, to the 14th power. So that leads us to this theorem that says the nth term of geometric sequence. So we're talking about geometric sequences in this whole section. If the first term is a sub 1 and the common ratio is r, the nth term is determined by the formula, and sorry about this comma, I should have gotten rid of it, a r to the n minus 1 power, as long as r is not 0. You can see where r being 0 would make a very boring sequence. So here's a sample homework type problem. Find the 5th term. So a sub 5 equals a1 times r, which is negative 2 to the 4th power. So hopefully you can see that putting a negative number in there is going to make the sign alternate as the power on the r switches from even to odd and vice versa. So negative 2 to the 4th power is negative 2 times negative 2 times negative 2 times negative 2 is 16. So this is 6 times positive 6, or 96. So this is the 5th term. And then the nth term is 6 times negative 2 to the n minus 1 power. Okay, and let's look at number 24 together. So this example number 28, it asks you to find the 8th term. It doesn't tell you as much about the sequence to start with. We can see that the a is 1. That's always the easy thing to pick out. But then hopefully you can see that 3 divided by 1, 9 divided by 3, the r that we're multiplying by is 3. So the 8th term, a sub 8, would be 1 times r, which is 3, to the 7th power. And my brain's not awake enough yet to tell you what that is, so use your calculator and write out what number is 3 to the 7th. Okay, so here's some examples where you're given less information and you have to figure out what's the ratio. So 10 divided by 5 is 2. 20 divided by 10 is 2. 40 by, so it looks like the R is 2. And A sub 1 is always the fifth term. So the nth term is found by multiplying 5 by 2 to the n minus 1 power. So then if I asked you what a to the 7th is, you'd say that's 5 times 2 to the 6th power. So that looks like 5 times 64, or 320. So aren't you glad we don't have to write out all the terms to find the nth one? And then number 40 I'd like to talk about together because it has kind of an interesting little twist to it. So then let's talk about what happens if you add up the first n terms. So again, this is a finite sum. Okay, so this is we're first talking about a finite sum, just like we did with the arithmetic. So we're going to sum the first n terms of a geometric sequence. So the sequence is the list, and we're going to add the terms of the list together. So if you have a geometric sequence and you start adding the terms together, we use the same notation, S sub n. So S sub 5 says, add together the first 5 terms. So that's how you read that notation. It's called a partial sum. So S sub 5 says add the first 5 terms. So there's a formula again, and we could derive it, but it would take longer than deriving the arithmetic one. So we're just going to believe the people that figured out that if you take A1, the first term, and you multiply it by 1 minus r to the n over 1 minus r, that gives you the sum of the first n terms. So if you wanted S sub 5, you'd take your first term and you'd multiply it by 1 minus whatever your r is to the 4th over 1 minus your r. And there is a proof in the book if you want to see how that's worked out. Okay, so let's look at some examples. This first one is the same one that we looked at earlier, actually. So you can see that the first term is the 3/9 or 1/3. And the r is 3. You're multiplying by 3 each time. So the S sub n equals 1/3 times 3 to the n minus 1. And they're just leaving you with an n at the end. So we can't actually find a number for the sum. We're just finding a formula for the sum. Sorry, this is for the a sub nth term. But the S sub n would be a sub 1, which is 1/3, times 1 minus, your r is 3, to the n over 1 minus, your r is 3. So order of operations would say it's 1/3. You do the 1 minus 3 to the n part, and then you divide by -2. Or you could simplify this to -1/6 times 1 minus 3 to the n. So for instance, if you wanted S to the 7th, it would be -1/6, 1 minus 3 to the 7, and that would give you the sum of the first 7 terms. And you see how it would come out positive, because 1 minus 3 to the 7th is going to be negative, but then I'm multiplying it by negative. Okay, so let's look at the other two in class together.